So students, this is my second video on polynomial. In my first video, I have explained the properties of the polynomials, what is the degree of a polynomial, what are the terms, what is the coefficient, and I have explained about the zero of polynomial. So before starting on to the remainder theorem, I will just revise what is zeros of the polynomial. So the definition is, if C is any number which is zero of a polynomial, if we say that C is any number which is 0 of a polynomial, then if we substitute the value of x or y, whatever is the algebraic number is there, with C, the value of it becomes 0. So PC will become 0. So this is what I have written here as a definition of the 0 of a polynomial. For example, if there is any polynomial Px, x square minus 4x plus 4, you know that the highest exponent is 2. So it is a polynomial of degree 2. It has 1, 2, 3 x square minus 4x and 4. There are 3 terms. So it has 3 terms. The degree of the polynomial is 2. The coefficient of x square is 1. The coefficient of x is minus 4 and 4 is another constant number. Now if you put x is equal to 2 into this, we see that p of 2 is 2 square minus 4 into 2 plus 4. So this will become minus 4 minus 8 plus 4, which is giving the value as 0. You can check. Therefore, we say that x is equal to 2 is a 0 of a polynomial. What does this mean? If x is equal to 2 is a 0 of a polynomial, then we say that this polynomial will be divisible by x minus 2, and the remainder will be 0, and the remainder will be 0, because when we substitute the value of x as 2, we get the value of a polynomial as 0. So it will be divisible by x minus 2. So this is one of the concepts which we are going to use for remainder theorem. Now the second point is, let us take a constant polynomial. If I take any constant polynomial 5, I have already told it can be written as 5 into x to the power 0. X to the power 0 means any number to the power 0 will always be 1. Since this is a constant polynomial, hence it has no zeros. There cannot be any zero of any of the constant polynomial. This is you have to remember. Now if px is equal to 0, if the polynomial itself is 0, which is a 0 polynomial, then we can write px as 0 into x to the power n. X to the power n, or anything we can write, plus 0 into x to the power n minus 1 means all the coefficients which I have explained in a standard form. If it is 0, then the degree of the polynomial, then we say that it is a 0 polynomial because the value will become 0. Now we see that whatever the value of x we substitute, we always get px is equal to 0. Therefore, we can say that x to the power n, x to the power n into 0 will yield 0. So every real number, any number, if we substitute any value of x, we will get the value of the polynomial as 0, because the coefficient is 0. Number multiplied by 0 will yield 0. So every real number is a 0 of a 0 polynomial. This I have written in red. You must understand why every real number is a 0 of a 0 polynomial. So these are important points about the polynomial. Now some more points which you should know about the polynomial. A 0 of a polynomial need not be 0. The 0 of a polynomial need not be 0. I have explained above. There can be, see, any real number. The real number is a 0 of a 0 polynomial. So we can always say that 0 of a polynomial need not be 0. Here in this example also, 2 is the number which is yielding the 0. Therefore, we can say that any non-zero number can be a 0 of a polynomial. Now second point is, 0 may be a 0 of a polynomial. Yes, 0 may be a 0. I will take one example. If I take a polynomial x square plus 2x which has two terms, the degree is 2. If I put x is equal to 0, I get px is equal to 0. Therefore, x is equal to 0 is a 0 of a polynomial, because if we put the value 0, we get the value of the polynomial as 0. Therefore, 0 may be a 0 of a polynomial. It is possible that 0 may be. I have explained it with the help of an example. Now, we will come to another important property, that every linear polynomial has one and only one zero. Of course, linear polynomial means it has degree 1. So, if I write px is equal to ax plus b, and if I equate it equal to 0, I will get only one value of x, which is minus b by a. So, every linear polynomial means the degree of a polynomial is 1. So, it has only 1 and 1 0. Okay. Now, the fourth point is, a polynomial can have more than one zero. This is true if I take an example, px is equal to x square minus 3x plus 2, which is again a polynomial of degree 2. If I put x is equal to 1, I'll and we check that we get the value of p1 is equal to 0. But if I put x is equal to 2 also, then also we will get the value of polynomial p2 is equal to 0. Therefore, a polynomial can have more than one zeros. So, this points you should understand and remember, because these are all important things before we now come on to the concept of the remainder theorem. The remainder theorem, I will come first to a simplest division which we have been doing from class 1 2. So, if there is any number 15, if I divide it by 6, so I will get 2 as a quotient, divisor is 6, dividend is 15, and the remainder what we get as 3. So, 15 can be written as 6 into 2 plus 3, or in general dividend can be written as divisor into quotient plus remainder. This you all know from the previous classes, and from the very starting classes, this you must have all read in mathematics. Now, I am going to apply the same concept on algebraic expression, that is polynomial. So, the same thing we are applying here to polynomials. Here the only difference is we are not having a simple number. Rather, we will be dealing with a polynomial. Now, we am taking an example. Suppose there is a dividend one polynomial px is equal to x square plus x minus 1. This is the polynomial. And if I divide this polynomial with x plus 1, then what is we are going to get? You see that we are getting remainder as 1. So, I can write dividend is equal to divisor into quotient. So, this is dividend, this is divisor, this one is quotient, and this one is remainder. This one is remainder. So, I am writing, because all these you see, all these are polynomials. This is a polynomial of degree 2, this is polynomial of degree 1, this is polynomial of degree 1, and this is a constant polynomial. So, I can write px is equal to gx into qx, because I am representing any polynomial by px. So, it is gx into qx plus rx, where rx is the remainder polynomial, qx is the quotient polynomial, gx is the divisor polynomial, and px is the polynomial itself. Okay. So, here I can write qx will be nothing but 3x minus 2, and rx will be 1. Hope you would have understood how we write a polynomial when we divide it with a divisor and get the value of and get the remainder and quotient. So, here you have to understand that we can divide a polynomial by a polynomial whose degree will be either less than the polynomial, or at the maximum it will be equal to the polynomial. So, we can divide a number, any number 15, if I divide it by 16, it will be difficult for us because we may get in decimals. So we may get the value in decimals. So the degree of a polynomial of px will always be greater than or equal to the degree of gx, because with a higher polynomial, with a higher degree of higher polynomial, we cannot divide. So the degree of px will be greater than or equal to the degree of gx. Okay, therefore the divisor has degree less than the degree of the main polynomial, then only the division will happen. And the second is the degree of a remainder, because whatever remainder we are getting, it should always be less than the degree of gx, of course. Then only we will get the remainder. As long as the degree will be equal to the degree of gx, it has the divisibility, it can further be divided. Therefore the degree of rx will be less than the degree of gx. I mean to say that remainder will always be less than divisor. The remainder will always be less than divisor. So same is the degree of Rx will always be less than degree of Gx. Now in this particular case, we get the divisor is x plus 1. It has a degree 1. Therefore, the remainder will have the degree 0. The degree 0 means this will be a constant polynomial. So I have written this so that you understand it in a better form. Now with this concept, I will now come on to the interesting theorem which is called as the remainder theorem. Now before explaining this, we write back some polynomial which we have explained above in divisor, quotient and remainder form. I'll just explain once again. 3x square plus x minus 1, I have divided it and got x plus 1, 3x minus 2 plus 1, I have written it above. So now Px can be written as Gx into Qx plus 1. This is one of the form. This is how we have written. Now if we put x is equal to minus 1 or x plus 1 is equal to 0. So if I make x plus 1, yani Gx, if I make Gx is equal to 0, Gx is equal to 0, what we get, P of minus 1 will be 0 into 3 times of minus 1 minus 2 plus 1. I get P of minus 1 is 1. I have substituted the value of x as minus 1 in the polynomial. In the polynomial, I have substituted this value, so I have got 1. So I have got 1 here. So you can see that P of minus 1 is 1. So remainders can be directly obtained by putting the value of x is equal to minus 1. Here I can directly get the remainder because this is the remainder. I am directly getting the remainder by putting the value of p as minus 1 because my quotient is becoming 0. So the remainder value will be p of minus 1 is 1. And you know, while we have divided it by x plus 1, we have divided it by, we have got the remainder as 1, which is very clear from this concept of remainder theorem. Now, you can understand, if polynomial is 3x square plus x minus 1, if I put p is equal to px is equal to minus 1, what we will get? 3 times of minus 1 square plus minus 1 which is 1. So we got the remainder. So this is very interesting, which is explained with the remainder theorem, because this part has become 0. So remainder is minus 1. So we can directly obtain this expression remainder by putting the value of x as minus 1 and the remainder is coming out as 1. For better understanding, I'll take up one more example. Here, the polynomial is 3x to the power 4 minus 4x square minus 3x minus 1 is 0. Now, if I divide it by x minus 1, so the divisor is x minus 1. Divisor is x minus 1, and if I put divisor is equal to 0, x minus 1 is equal to 0, or if I make gx, which will be divisor, is equal to 0, this will give x is equal to 1. So if I put x is equal to 1, as explained above, divisor x minus 1 is equal to 0, so I will get x is equal to 1. So I substitute the value of x as 1 in the polynomial and I get p1 is equal to minus 5. So I will do now actual division. So by dividing it by x minus 1, we will get the polynomial, we will get the remainder as minus 5. I will explain this now by doing the actual division. Here I have explained the steps of the division also, so that it becomes easy for you. 3x squared, 3x to the power 4 minus 4x cube minus 3x minus 1. So x minus 1. So my first term of the quotient will be 3x cube. 3x cube into x will become 3x to the power 4. So 3x to the power 4 minus 3x cube minus 3x cube, because I multiply this I will get minus 3x cube. So I subtract it, I will get minus x cube minus 3x minus 1. So the steps continues, because this is a simple division. You can check it in my video. This is a simple division, and how we have chosen the different terms of the quotient, those have been explained with the steps, because now I am getting minus x cube. Now here I am getting minus x cube. So to get minus x cube, I have to multiply x minus 1 with minus x square. So the first term is x. So I multiply with minus x square, so I get minus x cube with minus x cube, and if I multiply minus x square with the second term, I'll get plus x square. Now if I subtract it, I'll get minus x square minus 3x minus 1. So this continues, and when we continue and we come up to the last step I am getting is minus 4x minus 1. Minus 4x minus 1. So I am multiplying to get minus 4x. I have to multiply x minus 1 with minus 4. So I will get minus 4x, and minus 4 into minus 1 will become plus 4. So when I subtract, minus 4x plus 4x will cancel out, and I get minus 1, which is the remainder. So you can understand, by putting the value of x is equal to 1, I directly got the remainder, which I am getting from the division also. So this is the concept of the remainder theorem. So I will come on to the algebraic expression definitions of remainder theorem in my next video. In my next video, where I will explain it in terms of x. But this is the concept which is being used to explain remainder theorem. Thank you.